Welcome back to the Survival Historian, where we uncover the forgotten strategies that kept our ancestors alive, resilient, and building for eternity. Today we're stepping into the shadows of Europe's most magnificent medieval cathedrals, but we're not looking at the stone giants you've admired from postcards. We're going deeper into the unseen wooden skeleton that made the impossible possible. These weren't just houses of worship. They were survival structures of a different kind, monuments to human ingenuity, where master builders fought gravity itself with nothing but timber, iron will, and secrets passed down through generations of craftsmen. This is the story of wood, hidden in plain sight, bearing the weight of history. Stand before Notre Dame, Chartres, or Cologne Cathedral, and you're witnessing an engineering miracle. Walls of stone soar hundreds of feet skyward, ribbed vaults span impossible distances, and flying buttresses seem to defy the very laws of physics. Modern buildings crumble after decades, yet these medieval giants have endured wars, fires, earthquakes, and centuries of weather with a grace that baffles contemporary engineers. The question isn't just how they built them, it's how they're still standing. We've been taught to admire the stone, the stained glass, the Gothic arches, but we've been looking at the wrong material entirely. Hidden above the vaults, concealed within the walls, and long since removed from view lies the real secret. A vast, intricate network of timber engineering so sophisticated that modern architects are only now beginning to understand its genius. This wasn't decorative woodwork. This was the skeleton, the nervous system, the very heart that allowed these structures to breathe, flex, and survive. Climb into the roof spaces of these cathedrals, into areas the public never sees, and you enter a different world entirely. Massive oak beams, some weighing several tons, form forests of timber stretching into darkness. These hidden wooden frameworks, called roof trusses or timber roofs, are engineering marvels in themselves. Some, like the tragically lost roof of Notre Dame de Paris, contain timbers dating back 800 years, each beam precisely placed by craftsmen whose names we'll never know. Modern laser scanning and drone technology have revealed the staggering complexity of these systems, hundreds of interconnected members working in perfect harmony, distributing the crushing weight of stone vaults and lead roofing across networks of wooden joints. The medieval builders understood something we've forgotten in our age of steel and concrete. Wood isn't just strong, it's intelligent. It flexes, it breathes, it absorbs shock, and when properly treated and joined, it can outlast empires. The true genius of medieval cathedral construction lives in the joints themselves, those invisible connections where timber meets timber. Walk through a modern lumber yard and you'll see boards fastened with nails, screws, and metal brackets. Crude connections that rust, fail, and weaken over time. Medieval carpenters worked differently. They carved elaborate mortise and tenon joints, where one timber's precisely cut tongue slid into another's socket, then locked it with wooden pegs called trunnels that would swell with moisture, creating bonds that actually strengthened over centuries. Scarf joints allowed builders to extend timbers to impossible lengths by interlocking angled cuts that transferred load seamlessly from one beam to the next. Lap joints and dovetails created three-dimensional puzzles where every piece supported its neighbor, where stress distributed itself naturally through the entire framework, rather than concentrating at failure points. These weren't just connections, they were mechanical solutions to engineering problems we still struggle with today. The interlocking nature meant the structure could flex during storms or settling, absorbing movement that would crack rigid modern materials. It's architecture that thinks that responds to its environment with organic intelligence. But even the most brilliant joinery means nothing if the wood itself fails, and medieval builders, well, they knew this intimately. The timber selection process, you see, began right in the forest, where master carpenters would mark specific trees. Often years before harvest, they would choose oaks and chestnuts with the proper grain orientation for specific structural roles. Now, vertical grain timbers, they resisted splitting under compression, while different grain patterns provided tensile strength where beams would bend. The seasoning process, it was equally critical. Green wood was far easier to work with, but it would warp and crack as it dried, so timbers were often cut and allowed to cure for years before installation. Sometimes, they were even submerged underwater in rivers or carefully stacked in covered yards. Once shaped, preservation became paramount. Some timbers were charred on their surfaces, a technique called shosugiban in Japan, but known across medieval Europe. This created a carbon barrier resistant to insects and rot. Natural oils, resins, and even animal fats were applied to seal the wood against moisture. In some cathedrals, archaeologists have discovered evidence of lead or copper treatments in areas vulnerable to weather exposure, and the builders, they even understood that different parts of a tree had different properties. Heartwood from the tree's centre was more rot-resistant and reserved for ground contact applications, while sapwood was easier to shape for decorative elements. Wood wasn't working alone. Deep within the masonry, invisible to visitors, medieval engineers embedded iron reinforcements at critical stress points, tie bars stretching across naves to prevent walls from spreading, cramps binding stone to stone at vulnerable joints. These weren't afterthoughts, but calculated elements of a unified system where stone, wood, and metal each played their role. The wooden framework absorbed dynamic loads and seasonal movement. The stone provided mass and compression strength, and iron held specific points rigid when flexibility would have meant failure. Recent restoration projects have revealed the sophistication of this integrated approach. Drainage channels carved into wooden beams to direct moisture away from joints, lead flashing protecting timber ends embedded in masonry, even ventilation systems that allowed trapped moisture to escape before causing decay. The cathedral wasn't just a building, it was a living organism where every material supported the others in an ecological balance of forces. As we face challenges of sustainable construction and climate adaptation, these medieval secrets offer profound lessons. Contemporary architects are rediscovering timber framing for its carbon-sequestering properties and seismic resilience. The flexibility that allowed cathedral frameworks to survive centuries of storms and earthquakes is exactly what modern earthquake-resistant buildings try to achieve with expensive damping systems. The natural preservative treatments our ancestors used are being studied as alternatives to toxic chemical wood treatments. Even the joinery itself is experiencing a revival, with CNC machines now able to reproduce the complex geometries that once required years of apprenticeship to master. But perhaps the deepest lesson isn't technical at all. It's about patience, about building not for quarterly profits but for centuries, about trusting materials to work with natural forces rather than against them. The anonymous craftsmen who shaped those oak beams knew they'd never see their work complete, that they were building for grandchildren's grandchildren. And yet they poured their skill and knowledge into every joint, every beam, every hidden corner that no eye would ever admire. The next time you stand before a medieval cathedral, look beyond the soaring stone to imagine the hidden timber forest within, the intricate puzzle of joints bearing impossible loads, the carefully selected and treated wood that's been quietly doing its job for 800 years. These weren't just survival structures for weathering storms, they were survival knowledge encoded in wood and stone, reminders that with skill, patience, and respect for materials, we can build things that outlast empires. If this journey into hidden history resonated with you, hit that like button, share this video with anyone fascinated by forgotten ingenuity, and subscribe to The Survival Historian. We're here every week, uncovering the techniques that kept humanity alive, resilient, and reaching for the impossible. Until next time, stay curious, stay resilient, and remember, the greatest secrets are often hidden in plain sight.